Hey, welcome to the blue pen land here. I thought I'd do a problem where we shoot onto the top of a cliff. I think the formative assessment has one shooting from the top of a cliff, right? But here we're going to go onto the top of a cliff, right? Okay, so it's a situation like this where tall cliff, right? And then we're going to shoot at 61 degrees, right? So it's like, the thing's going to go and land on the top of it, right? Okay. What that means is that that it ends up higher, and so for our vertical displacement, we're going to say plus 122, and that'll make a difference. That'll make our final velocity a smaller number than our initial velocity. Okay, and then the things we know that are still true are that, right? We still know that, right? And now we got to get our initial horizontal and vertical velocity, right? And we'll do that from cosine and sine, right? So the horizontal is, so the initial velocity in the x direction will be 92.1 FM times cosine. Sad when I have to laugh at my own jokes. Okay, cosine of 1. Okay, and then I'm checking my mode here. I'm in degrees. Okay, so 92.1 times cosine of 61. Shouldn't be a lot, but it should be something. Okay, so that is 44.651. Right, and of course the final velocity, the entire time, the velocity is 44.651. Okay, I'm going to store that just for kicks in A. All right. Okay, so let's see. And then let's figure out our initial velocity in the y direction. That's going to be the opposite side here, right? So that's 92.1 sine of 61. Okay, 92.1 sine of 61. I'm going to store that in B just for kicks. And that's 80.552. Okay. So now we've got this, right? And I think this side's solvable, right? We've got 1, 2, 3 things here, so we ought to be able to solve that. This is, of course, quadratic, so I'm going to solve for the final velocity here, and then be clever about whether I choose the positive or the negative. And then we're going to figure out time. Time will go across, and we'll figure out everything, okay? Okay, so let's see. Double checking that. Yes, okay, so we're good. So the first thing I'm going to do is let's find this guy here. Let's find the final vertical velocity, right? So I'm going to choose this guy. Right, so V is the square root of 80.552 squared plus 2 times negative 9.81 times positive 122. Now here's where, if you look, this term here, right, 80.552, better when squared, it better be bigger than all of that multiplied together. Because if it's not, the cliff's too high, right? So let's just see. Let's see what it does. I'm going square root, left parenthesis, and then I stored this value in B, so I'm just going alpha B. But you could type 80.552. That's probably good enough. Plus 2 times negative 9.81. So don't forget the negative there, right? Times positive 122, right parenthesis. I'm going to store that in C just for kicks. 63.99, I'll say 993. Okay, and now we've got to decide, is it plus 63.993 or negative 63.993? Well, you know, we're not asking about on the way up. We're not hitting the bottom of the cliff somehow, right? We're hitting it from the top. We're going down. So we definitely are going to choose negative 63.993. And apparently, 122 meter tall cliff is nothing for this thing to land on top of. It's still going plenty fast when it goes past that, right? Okay, but that's crucial. We got to choose the negative, right? It's not CTR, it's CTN. Choose the negative, or choose the positive, right? Or you could choose the right. There we go. All right. So now let's find the time here, right? I'm going to use V equals U plus AT. So negative 63.993 equals 80.552 plus, I'm running out of room, negative 9.81 times my little bitty variable t. Okay, so let's see that guy, and then 80, oops. Okay, now divided by 9.81, I'm getting 14.734. I'm going to store that in t, because it's the time. Okay, 14.734, and then that can, of course, cross the blood-brain barrier. Okay, and now we're all set. Now we can figure out, all we ever do in the horizontal direction is find the, is just use S equals UT, right? Okay, so S is equal to 44.651, which I've stored in the variable A, times 14.734, which I've stored in the variable T. Okay, so I guess I'm just going to type A times T, alpha A, let's see, yep, times alpha T. I get 657.9. meters, right? So the answer down here is, what is it, 658 meters, right? And then it says, what is its speed of impact? The other things it asks is its time. What time is it in the air? So 14.7 would be our time. Speed, though, is hard, right? So let's figure this out. So here is our final velocity vector, right? This is meters per second in the x direction plus meters per second in the y direction. So our speed is the hypotenuse of that vector, right? It is, when it comes across, it's like, whoops. Here's our horizontal component, and then there's the actual thing. We don't have to draw this thing. I'm just doing it because I'm a geek. All right, so the hypotenuse of this thing, right? This side is 44.651, and this side is 63.993. Okay, and so the speed is the hypotenuse of that, right? Don't forget this. It'd be sad to do all this work and then, whoops, I don't know how to do the speed, right? So that's 44.651 squared plus 63.993 squared. I think that's my alpha C. Yep, alpha A. There we go. This is, for me, this is alpha A squared plus alpha C squared. Let's try it. Okay, alpha A squared plus alpha C squared. Variables, they're a way of life. 78.03 meters per second. So with with 3 sig figs, 78.0. All right, so the second part of this is, I think, simpler than the first part of the assessment. So enjoy.